Hello everyone, welcome to this session on land use land cover mapping using QGIS as part of the online training program on Introduction to Remote Sensing and GIS using QGIS. In the first week of the training program, we have seen the basics of remote sensing and GIS technologies, and then we started working with QGIS. We installed QGIS software on our systems, and we had seen how we can make use of delimited text data to generate vector layers, and we had seen open access a session on open access spatial data sets. We downloaded some vector data sets, and we have seen how we can manipulate vector data set vector layers and attribute tables to generate new vector layers. And then we have seen how to prepare a basic map using QGIS, and how to georeference a scanned map, and how to make use of satellite imagery for digitization and generation of vector layers. Then we started with working with raster layers. We have seen how the sources of downloading raster layers and how to load raster layers in QGIS, how to change visualization, and how to make use of raster calculator for doing the band math, or making use of multispectral imagery. Then we had session on basic spatial analysis, wherein we covered vector analysis as well as raster analysis, and how zonal statistics can give summary statistics of any raster layer for any vector polygon. Then we started with then we had a session on applications part. We used Saga tools and GRASS tools for processing digital elevation model and generation or delineation of catchment area for any outlet on the stream network that is generated. Then we had a session on QGIS plugins, and when we touched upon many plugins. We have been using many of the plugins during this training program. In that session, we also talked about a plugin known as semi-automatic classification plugin, SCP plugin, which we will be using in this session for preparation of LULC map for Pune region. As you are aware, the LULC map is a very critical input for hydrological modeling, as it defines how much rainfall will translate into runoff. And an up-to-date and a very reliable LULC map is often not available. So using SCP plugin, you can create your own LULC map. However, you need to for accurate mapping, you need to collect field sample data, and then you have to maintain quality control. In this session, we will be introducing you the plugin and how you can make use of it for generating LULC map tailored to your specific study area. You can further make use of this plugin for generating your own land use land cover maps. Yeah, let us start. The semi-automatic classification plugin, it allows for supervised classification of remote sensing images. It provides a set of intertwined tools for raster processing in order to automate the workflow and ease the land cover classification, right from the downloading of satellite imagery to pre-processing and then post-processing of images. It was initially developed by Luca Congedo in 2012. He keeps on updating the uh, plugin. The last update was done in November 2024. The current stable available version is 8.5.0. For more information about the plugin, including tutorials, video tutorials by the author of the plugin, you can visit this website, from GIS to RS remote sensing, from GIS to rs.blogspot.com. And you will also find a link to the manual at this, and you can access the manual at this address, semi-automatic classification manual.readthedocs.io. The plugin requires installation of remote earth sensors, NumPy, SkyPy, Matplotlib, and some a few other Python packages. And you may, if you want to, and there are also some optional dependencies, Python packages which you can install, because there are many. It is a very comprehensive plugin, having different algorithms for land use land cover classification. If you want to make use of machine learning algorithms, you can also install scikit-learn and other Python packages. Now for installation of semi-automatic classification plugin, we can go to this URL, the manual semi-automatic classification manual.read.docs.io, and go to the plugin installation section. We will be using OSGeo for Windows Network Installer in Windows, because this particular plugin requires some packages like remote ear sensors, GDAL, NumPy, SkyPy, and optionally scikit-learn and PyTorch are required if we are using machine learning algorithms for land use land cover mapping. So you can make use of this OSGeo for Windows network installer to choose the packages, Python packages for installation. So you can follow the steps as listed under this. So let me launch my OSGeo for W network installer, which we had downloaded earlier. Run it as an administrator, and then now check the advanced install option as you want to choose the packages. Then click next. Select the option of install from internet. Then you can continue. These are already you have the folder. And then direct connection. You go with the default option. Yes. When you come to this stage of selecting the packages, here you can go to this libs. You open this libs, and now we will search for our packages. Now in the menu select packages, you can search for, now QGIS as we have already installed a long-term release. Here they are asking for installation of full QGIS full free. Let us check with long-term release if it requires any additional packages. We will look it afterwards, but remaining things, like main thing is Python 3 remote ear sensors. This is the package, Python package, that is essential. So you can search for this here. You can enlarge this window and you search for, yeah. So currently the version 0.4 this version is already there. So if you want to check, you can click on this keep, whether there is any newer version is available. So I don't think you have there is any new version that is required to be installed. So you can keep it. So every time you click here with your left button, it will give you the options of reinstallation, then installation of a newer version, or uninstallation. Okay, you can keep it. Then the next thing is Python scikit-learn and Python 3 torch. So we will search for these packages and install the dependencies along with the dependencies. So dependencies, NumPy, all those things will be taken care of. Scikit-learn is not there installed on our system. You can then check this. Next one is PyTorch. PyTorch. Remote ear sensors, you can one more time, you can just check it. Otherwise also you can update any of the package afterwards also. Yeah, 0.4.4 is the current version. 0.3, okay, fine. You can keep it and then go ahead with, so what we have chosen, scikit-learn, PyTorch and remote ear sensors. Then click on next. So these are the dependencies which are required. Go next and let it complete the installation. It will not take much time. Once it is completed, you will get this message, installation is complete. You can click on finish and then go to your QGIS, launch you launch the new project and then go to plugins, manage and install plugins. Now you have to install the, now you have downloaded the required dependencies packages uh, which are required for SCP, and now you will install it from the plugin install and plugin manage plugin manager. You can click on install plugin. You search for semi-automatic classification plugin and click on install plugin. After successful installation of the plugin, you close the window. You will find that a new dock, your new panel of SCP dock is added below the layers panel, and also a new menu item SCP is added to your QGIS. One SCP plugin toolbar will also be activated. Like this is this one. This plugin, this toolbar was earlier not there. This is, you can check the under toolbars, a new plugin, a new toolbar, SCP working toolbar has been added. So now your semi-automatic classification plugin is installed. However, under the dock you will find this message. If you are finding this message, a new version of remote ear sensors is available. So you can update this package. How to do that? That is also mentioned in your installation manual. Yeah, the dependencies remote ear sensors is frequently updated. You can check automatically if a new version is available. How you can do is, you go to the OSGeo for Windows shell. Go to your C drive where you have this folder OSGeo for W, and here you will find this OSGeo for W. shell, double click it. Sorry, this is an image file. In the startup menu, you can look for this OSGeo for W shell, which will be installed, which must have been installed along with your QGIS network installation. And you click this, and here you can type this command. For upgradation of remote earth sensors package. Okay, it says it is already satisfied. No issue. So what we have done, we have used OSGeo for W network installer, advanced install, and we have chosen those three packages: remote earth sensors, PyTorch, and then scikit-learn. And then we installed all the packages along with the dependencies. Then we went to QGIS and then installed the semi-automatic classification plugin from the plugins, manage and install plugins. We have installed it, and you will find the SCP doc added here, as well as in the main menu item SCP is added along with the toolbar. Then you have seen this a new version of remote earth sensor is available, news, some message is there. Even otherwise, the installation manual says that it is recommended. You can close the QGIS and then run this command. You will find the command in the installation manual, for which the link is provided in the presentation slides, and you copy this and then launch the OSGeo for Windows shell, and you type this, you paste this message, the command pip3 install double hyphen upgrade remote earth sensors, and then it upgrades it upgrades the remote earth sensors. You can run it again. Yeah, so it is satisfied, and now you can now close this window and launch QGIS. Simply follow the steps listed in the manual. There are different steps for Windows installation, for network installation, OSGeo for W network installation, for Linux, for Mac. So you follow the steps which are there for the 2.2 section 2.2 under plugin installation, OSGeo for W network installer. You complete this, and then you launch again your now you are no longer finding that message of upgradation of the package remote earth sensors. Moving further, you have already been introduced to the concept of spectral signature and image classification in the second session on basics of remote sensing. To briefly recap, image classification is the process in which satellite pixels in a satellite image are grouped according to their spectral characteristics and subsequently assigned to various land use land cover classes. So every natural or man-made feature on the Earth's surface has a unique spectral signature. The distinct pattern showing how a feature reflects the percentage reflection on the y-axis, and x-axis the wavelength of the electromagnetic spectrum across the electromagnetic spectrum. This relationship, as you can see, it is represented as a plot of spectral reflectance, which helps in identifying different surface materials such as vegetation, soil, water, or built up areas. It is very easy to identify the broad classification, broad land use land cover class. It is very easy to mark water, map water. It is our vegetation. However, within vegetation, if you see, there is a very subtle difference between, say, coniferous forest and deciduous forest are different between different crops. So it will be there for categorical specific classification, it will become difficult. When multispectral imagery is available like this, each pixel records reflectance values in several spectral bands. So since Earth's surface feature has its own characteristic spectral response, it becomes possible to use different combinations of these bands to identify and classify surface features into specific land use land cover categories. This is what we do while generating the LULC map. There are two ways of doing it: supervised classification and unsupervised classification. In supervised classification, if ground information, ground truth data is available, that is when the known land use land cover information from the field surveys is collected, or other reliable sources if you have collected, if it is available, it can be used as training data. You create training samples for known classification. Training samples in this SCP plugin, they are also known as regions of interest, ROIs, for each class, for each known class. Now the spectral characteristics of, then once you have the training sample, the spectral characteristics of unknown pixels are then compared with those of the training samples, and that unknown pixel will be assigned to the class which is having the most similar spectral profile from the training samples. So the accuracy here, it depends largely on the how good are your training samples. Some of the general guidelines that you can follow to improve the classification accuracy are: the number of the training samples should be well distributed throughout the image, not concentrated in any part of the image. Then number two, each class should capture sufficient spectral variability within that category. For example, if you take water body, there may be deep water bodies, there may be shallow water bodies, there may be water bodies with a lot of sediment. So you should capture all the variability within that image for mapping of all the water bodies. And there should be at least 5 to 10 training samples per each class. And the training areas should be homogeneous, representative, and clearly defined. And once you follow these practices, the classification results will be better. The other category, unsupervised image classification, where you don't provide any prior ground data, truth data. You mention the number of clusters that you want, and the software automatically groups the pixels into clusters based on their spectral similarity, how are their spectral reflectance curves, using statistical methods. And you only have to provide the desired number of classes. And after clustering, these spectral classes are interpreted by and labeled by the analyst or the user into meaningful land use land cover classes. That is what happens in unsupervised image classification. However good you are while doing this classification, how many training samples that you may collect, there will always be scope for error. That means your accuracy will never be 100%. That is why we always associate with LULC map what is known as accuracy matrix or error matrix. What we term as we conduct accuracy assessment. Why it happens? Because of several reasons. When you are dealing with multispectral imagery, there will be cloudy pixels, there will be cloud shadows, there will be mixed pixels containing multiple land cover types. For example, if you take the Landsat imagery in a 30 by 30 meter resolution, especially in urban areas, it may contain buildings, it may contain vegetation, it may contain bare soil. There will be a mixed spectral signals coming. And also other sources of error are when you have defined your training sites poorly, or failed to capture the full variability of the class, like I said about water. Similarly, about if you take vegetation, it may be also be having lot of variability within the same image. If you want to capture, you have to capture the whole variability of the class. And there are some classes which are spectrally similar. For example, forest areas and crops. Even though you can make use of NDVI value and the cyclicity, like NDVI values in case of crops, it will there will be it will vary in a cyclical manner depending upon the sowing time and harvest time. Whereas in case of forest, the NDVI value, especially in evergreen forest, it will remain constant. So you can add such additional information from NDVI to separate. Otherwise, the spectral curve will remain the same, will look similar. That is spectral similarity. Similarly, there will be spectral similarity between bare soil and built up area, and there will be misclassification. Also, as we said, coarse spatial resolution, it may not be able to capture fine scale variations. Such problems can be minimized when you can use higher spatial resolution imagery such as Sentinel-2 multispectral imagery, which is available at 10-meter resolution. Several satellites, multispectral satellite, Earth observation satellites provide multispectral data useful for land use land cover mapping. During this training program, we will focus on optical and infrared regions of the electromagnetic spectrum. We will be using either Landsat or Sentinel-2 imagery. The Landsat program was launched jointly by NASA and USGS, United States Geological Service, and in the year 1972, and it has been continuously acquiring Earth image since then. Because of this long temporal series, it is very valuable for change detection studies. The spatial resolution is 30 meters, as you can see, most of the bands. The Landsat 8 and 9 are operational. The sensors are OLI and thermal infrared sensor, but thermal bands which we don't use it for land use land cover classification. The key bands for land use land cover classification, if you can see, band 2 blue band 3 green, band 4 red portion of the electromagnetic spectrum, and band 5 near infrared, and then band 6 and band 7 shortwave infrared 1, shortwave infrared 2. When it comes to Sentinel-2, it is has finer resolution. It is from European Space Agency under the Copernicus Land Monitoring Service. It acquires imagery in 13 multispectral bands and has most of the bands are at the spatial resolution of 10 meters. There are other bands at 20 meters and 60 meters. So for land use land cover classification, you can make use of band 2 falling in the blue region of the multi electromagnetic spectrum, then band 3 green, band 4 red, and then band 8 near infrared, and then band 11 and band 12 shortwave infrared 1, shortwave infrared 2. As I said, thermal bands are not generally used as they measure emitted rather than reflected radiation. You can launch the semi-automatic classification plugin from the toolbar by clicking on this icon of semi-automatic classification plugin, or you can launch it from the main menu SCP. The first step will be downloading of multispectral imagery. So here you have two tabs of login data and search. Instead of downloading the data from the portals such as Copernicus Data Space Ecosystem and NASA Earth data, you can download you can fetch the data directly from the plugin. So this plugin provides you it also allows you to download products. So for that you need to provide your username and password. We had suggested you to create a username and password login credentials for this Copernicus data space ecosystem when we introduced you to various open source spatial data sets. And also you can make use of Earth data, NASA Earth data login for fetching harmonized Landsat Sentinel-2 imagery. But we will be we will use the Sentinel-2 imagery, multispectral imagery, which we have just seen that it is the finest resolution multispectral imagery which is available in the public domain at 10-meter resolution. So you can provide your credentials after creating them. You can save the password here. Every time you can fetch the data directly from the plugin itself. And you can save the, you can check this box, the password. It warns that the password is stored unencrypted. You can click OK. And now you go to the tab of search data. Either you can provide the coordinates of a bounding box by providing the top leftmost corner of the bounding box and the right bottom most corner of the coordinates of the right bottommost corner, or you can make use of the map to identify to set the area in the map. But for that you will be requiring a base map. You can add the base map from here. You can see this OSM. This will add OpenStreetMap to the map canvas area. You can check after clicking. You see the OpenStreetMap is added, and here I will close this SCP doc. I will be using it at the time of preparing training input. And now you know from the status bar you can make use of this nominatim geocoder. Double click it and then choose your area of interest, type it, and then click in the results to go to the your area of interest. So this is again the extent of Pune city with surrounding areas. Now you can use this mouse button to just adjust the extent so that it covers all the land use land cover classes that you may have in the mind, like water body, then hill ranges and some forested areas, then the main city urban built up area, and then the downstream there will be some agricultural areas also. So you can so now you can set the area in the map. Again you can go to the this option which is set area in the map. Click it and then go to the map canvas area. With your left button of the map, you click the left topmost corner somewhere here, and then the right bottommost corner again with your right button of the mouse, you click here. Then it will, as you can see, this area it has set in the map. Now for this area we can search for the data sets which are available. We will search for the Sentinel-2 data. The product will be Sentinel-2. As you can see, it is populated. The bounding box has been populated based upon the area that you set. And you can search for the date range. You would like to avoid imagery where there is high cloud cover, because cloud cover will interfere with the spectral reflectance or spectral response of the features on the surface of the earth, and you want the features to be identified by their spectral signature curve. So let us say, let me choose an area, date range of say I will choose February month of 2024, last year. So from 1st February to say 28th February, sorry, 29th February 2024. That is the date range. And the number of results that you want to be displayed, you can keep it, say, default 20. And then now you click on this. Yeah, the maximum cloud cover You can decrease, you can filter out the high cloud cover percentage. Say you can keep it 20 or 30, but let it remain. We can, because you will also get the information about the cloud cover in the search results. There you can filter. Now you click on this find images. It will get the information from the Copernicus data space ecosystem. Wait for it. So these are the results. We have 11 results, and you have the all of the products are Sentinel-2, but there are two types of products: L1, that is level 1 product, and L2, level 2 products. Now level 1, we talked about it in one of the earlier sessions. Level 0 are always raw images. Level 1 products are top of atmosphere reflectance products, and level 2 products means surface reflectance, and level 3 are scientific products. Now you would like to make use of surface reflectance products because they are generated after removing the atmospheric disturbance through some algorithm. So from the top of atmosphere reflectance, you remove the atmospheric disturbance to get the surface reflectance. So surface reflectance products are more suited for land use land cover classification. So yeah, you can see, and the cloud cover, you can see there are imagery with cloud cover, even though there is one image with 79% and then 14%, 18%. So you also have imagery of land level 2 product with least cloud cover. So you can select some imagery, say this one. No, this is 14, and you can see the preview here. Preview in the right side, there is it is showing the preview. So you can select 0% cloud cover from the dates, say yeah, and you can check the preview, and this imagery, it covers the selected area, the main city as well as the surrounding regions. I think that is we can go for it. Now to download, you can select the you can also before downloading, you can also display the preview of highlighted images in the map. So if you click this in the map canvas area, you will find that a low resolution temporary layer has been added. Anyway, we can skip the step, it is still taking time. It is just an image. Now we have to download the band, and now you can select the bands, all the bands that you want to make use of. The more the number of spectral bands that you make use of, the better will be the your LULC classification. Instead of relying on one or two bands, you can make use of multiple bands, but you have to make use of the electromagnetic spectral bands. Thermal bands are generally avoided because they are emitted reflectance. They are not. They are emitted radiation. They sense emitted radiation, not the reflected radiation. So you can see band 1 is aerosol band, which is close to blue band. You can remove it. And then band 2 is blue band, band 3 is green, band 4 is red, and band 5, 6, 7 they corresponds to vegetation edge. Then band 8 is near infrared. Then band 9 and 10 are thermal infrared. So you can uncheck them. You don't want the thermal infrared imagery to be included for LULC classification. 11 and 12 again shortwave infrared 1 and 2, you can include it. You can include also the ancillary data. And then you can see check this, you can keep as it is only if preview in layers, and you can uncheck this pre-process images. We will do the pre-processing separately, and then you can check this box of load bands in QGIS. Okay, so once you select these bands of 2, 3, 4, 5, 6, 7, 8, 8A, 11, 12 ancillary data, and then check the boxes of load bands in QGIS and uncheck the pre-process images and retain the only if preview in layers. Now with these options you can click on run. Then it will fetch and download the data, and where it will download you have to specify the folder where you want the data to be downloaded. So you can create a new folder, exercise data session 16. You can select this folder, so then the download will start. So it will fetch the data from Copernicus data space ecosystem, and you can see the progress of your download in the main canvas uh, of the QGIS, which will show the elapsed time as well as remaining time. It will take approximately 5 to 6 minutes of time for downloading all those bands. So let's wait for it. Once the download is completed, you will hear a sound which is characteristic of SAP plugin. Uh, that is indicative of the completion of the download, and the layers are added because you have checked in the box to add the layers. So you can check the layers of spectral bands. You can remove this preview layer. So how many bands are added, you can check. We have selected band 2, 3, 4, 5, 6, 7, 8. 8 we have two bands, two times it has been added. Then 8A, 11 and 12. So for the extent that you have chosen, you can check the folder where you had downloaded the data, exercise data. So you see one new folder is created, Landsat level 2, sorry, not Landsat, Sentinel level 2 data from February 28, 2024. You have the auxiliary file and as well as the individual bands 2, 3, 4, 5, 6, 7, 8, 8A, 11 and 12. I will remove this additional band. You can zoom in and check the resolution, which is 10 meter. Zoom to layer. The whole tile covers larger extent, but however for your set area, which was like this region, so this completes the first step of downloading the products directly in using the SCP plugin. You can check the metadata or properties of these layers, any of these layers. Like B2, this corresponds to blue band of Sentinel-2. Right click and click on properties. In the information tab, you can check the extent, width, height, and then yeah, the pixel size is 10 meters. Number of pixels, you have 10980 into 10980. Then the CRS, it is a projected coordinate reference system, which is the UTM 43 North zone. So it is already a projected coordinate system, whereas our project CRS is EPSG 3857, because the first layer that we have added is OSM standard layer. So you can change it to 32643. And one tip for increasing the download speed, in case if you are facing an issue with the download, please don't select a very big area, because for even for land use land cover map generation, your area has to be it has to be small, the extent should not be very extensive area. Then there will be an issue with running the plugin, running the tool itself. So I had chosen a part of city, like somewhere like this. So to increase the download speed, you can change one setting. You can go to SCP menu, and go to the settings, and here click on processing setting, and there will be an option of available RAM. By default it is about some value which is given here, 2 GB, about 2 GB. You can increase it to 50% of your system RAM. Suppose if your system is a 8 GB RAM, installed RAM is 8 GB, you can increase this to 4 GB. If it is 16 GB RAM, you can increase to 8 GB RAM. So you can do that. 4096. Now if you also check the values of the pixels by selecting the layer, you will find that these values are not actually reflectance values but some digital number. We need to convert them to reflectance values. So in the next step, in the SCP main menu, you can choose the option of pre-processing and then click on this image conversion. Select this image conversion option. Now you can select the directory containing the bands. You can give this exercise data. Inside that data, a new folder was created. You can select this folder containing the bands. So you will all the bands are listed here from B2, 3, 4, 5, 6, 7, 8, 8A, and then 11, 12. And yeah, you have this which data to use as no data. So that is not very important, but still, if the no data value is defined here, no. So keep it the default one, and then this let it remain unchecked. This is apply DOS1 atmospheric correction, because we are making use of level 2 products of Sentinel-2, that is surface reflectance product. So you need not apply this DOS1 atmospheric correction. DOS means dark object subtraction correction. That is not required. And then let create the band set and use band set tools. That you can uncheck and let the create a new band set. You keep this on, create a new band set option on. Now you can run the pre-process. You can click on this run button and you can create a new folder inside the folder of the Sentinel-2 where you had downloaded. Inside that you can create a new folder of converted and then select that particular folder. Create a new folder and then select that. Then it will start running and you will also again find the progress in the main canvas area. It will not take much time. So you will see the time that has elapsed and the time remaining. In the next step, we will clip our imagery, satellite imagery, the bands to area of our interest after this pre-processing step. So it is showing 15 seconds. Yeah, once you hear that sound, that means that process is completed, and you can check the folder where you created the converted folder, and you will see inside it you have again the same number of bands: B2, B3, B4, B5, B6, B8, 8, 8A, 11, 12. With a prefix of RT, that means converted files. These are all TIFF files. Earlier these were of JP2 files. They have an extension of JP2, the original files. In the next step, we will clip these bands, raster bands, to our area of interest for which we want to generate the land use land cover map. Before that, you can change the project CRS from EPSG 3857 to 32643, which is there in the recently used CRS, and you can apply it. Now you can check these. Initially the values of the pixel values were digital number, then we converted into the reflected values. Now these were the original. I think these are the ones after pre-processing. We initially the values were digital numbers. You can remove all these bands and then add the converted bands. Right click, remove, then add, open, click on open data source manager, and then add those raster layers. You can check the values of the pixels now. Say band 2, you click on identify features. The values are now reflectance values. As you can see, they are less than 1. Now we have to set the area of our interest. for which you can go to this SAP plug, plugin main menu and then click on band set. Now we have to define a band set. Band set is nothing but input images which are considered for further analysis. You can add all the bands which are added in the QGIS map canvas area. Add bands loaded in the QGIS. You can click on this symbol. Then you can select all bands. So you can see the bands 2, 3, 4, 5, 6, 7, 8, 8A. You can move to the top. Before that, let us change the band quick settings. In this wavelength, you can check Sentinel-2, and wavelength unit you can choose micrometers, and date of acquisition of the image you can change it. This image is from the year 2024 February. Yeah. So once you do that, the bands are automatically arranged as per the central wavelength. So B2, B3, B4, B5, 6, 7, 8, 8A, 11, 12. 10 bands are there. Now we have to we have to clip the bands, these bands. For that you will have this option under pre-processing, clip raster bands. So here now you have created a band set which is the active band set one. Okay, and then we will use it as an input for pre-processing, further pre-processing for clipping the raster bands. Where you select the input band set, there is only one input band set, that is 1, and output name prefix you can keep it as clip, that is the newly created bands after clipping they will have the prefix of clip, and then either you can give the coordinates for clipping or use a vector layer for clipping, or you can set the area in the canvas in the map by clicking this button and go to the canvas area. So the full extent of the Sentinel 2 you can see. Let me go to the pan button. I will pan the image. Yeah, this is the full extent. So I would like to set my area covering some of these lakes, forest area, and then the main city and some part of the agricultural commands in the downstream. So I can click with my left button of the mouse, click the left topmost button, and then right bottommost you can click the right button of your mouse. So then you can in this way you can set the area, and now you run your tool of clipping the raster bands. So inside this you can create another folder, clipped, and select this folder. So it will start running, and then each of these bands, 10 bands, will be clipped to the extent given, and once it is done, these layers are added to your QGIS layer panel. Now you can retain all those layers with prefixed clip and remove the remaining layers prefixed with RT standing for reflectance. Right click and remove them. So after completion of this step of pre-processing, you have 10 bands added to your QGIS layer panel. In this step number 4, we will create the training input file. So these are the bands which you have clipped. This is the extent for which you want to generate the land use land cover map. Now you can go to SCP main menu and then click on band set. Now you have to delete this old band set which is no longer useful, as now we have to define a new band set with the clipped layers. So you can select this band set and then use this option of deleting. Yeah, are you sure you want to remove the selected bands from the band set? Yes. In fact, you can select all these rows and remove from the band set. The band set is also deleted. Now to add new bands, you can load the bands which are add the bands which are loaded in the QGIS by clicking this symbol and click this select all. Okay, now the clipped layers are added, and you can do the band quick settings by selecting Sentinel-2 and then wavelength unit as micrometers and then the date as the date of the imagery. So you have a new band set created which is arranged as per the central wavelength, as you can see, 10 bands. Now we will use this as an input for further SCP classification. Now let us go to the SCP doc by going to view and then panels. You can check this SCP doc panel and go to the training input tab, where you can create this second button. Click on the second button of creating a new training input. Now the training input is this file will have all the training samples that we will be creating for land use land cover mapping based upon spectral similarity. So it will have an extension of SCPX. Now you can give a name of training input, the extension SCPX. You can save it in this folder. So we have created a new training input file, which is actually a temporary layer. As you can see, a temporary layer has been generated, SCP training layer. Now in the next step, we will create region of interest and then add them to the training input layer and then get their spectral reflectance curve. Training sites or region of interest can be manually created using this polygon drawing tool in this SCP plugin toolbar. You can hover your mouse to this tool which says create a ROI polygon, or you can use this one, active ROI pointer. Or now the difference between these two is, like, in case if you want to draw ROIs or polygons or areas where the land cover is uniform, for example the water bodies. Now let me if you bring the band 8 onto the top, which is NIR band. Yeah. So here you can see water bodies, they are mostly they're uniform. They are spectrally homogeneous. Deep reservoirs. I am talking of deep reservoirs. Similarly, if you have dense forest patch, uh, uniform patch, then are an extensive open land. So in such cases, you can make use of this, create a ROI polygon for creation of training samples. But however, if you consider the urban areas where we have multiple land use land cover types like built up areas, parks, roads, bare soil existing in close proximity, it becomes very difficult to create homogeneous ROIs manually. In such cases, we can make use of this activate ROI pointer tool, which is actually a region growing algorithm wherein you have to select a seed pixel and then specify a spectral distance threshold, and then the plugin then automatically groups all neighboring pixels within the which are falling within the spectral distance. Then it will create an ROI. This approach is very useful for creating training inputs for urban built up areas and other spectrally mixed features. We will use both these tools, polygon drawing tool and the region growing algorithm, to create multiple training sites, samples uh, for, for different LULC classes. One more thing is this macro class MC name and class name. Now we can work with macro classes which are broad categories comprising several subclasses. Now for example, macro classes could be water, vegetation, built up and bare soil. Water can be treated as macro class with subclasses like reservoirs, lakes, canals, shallow ponds, rivers. Each of them has distinct spectral characteristics. Similarly, vegetation macro class can have forests and croplands, and also urban, say urban parks or grasslands as subclasses. So we can do broad classification using macro classes such as vegetation, water, built up area, bare soil, and we can otherwise you can have detailed classification using subclasses, but for that you need to have training samples for each of the subclasses. So if you are following the best practices for creation of ROIs, you can create a very good LULC map. Like what are those best practices are the guidelines. You have to create multiple ROIs per class, like 5 to 10, to capture the spectral variability all over the image, and then several and these ROIs have to be spread through the across the entire image rather than concentrated in one particular area. And the polygons covering homogeneous regions represent the same land cover type. They should not include any mixed or other land use land cover type. Like for example, in a reservoir, there may be a small outcrop, rocky outcrop or island. While creating a polygon, make sure that you are not including that inside your polygon. Avoid including pixels of other classes within the ROI boundary. Otherwise, it will distort the spectral signature. If you follow these steps, guidelines, you will obtain very high quality training inputs. Then we can also make use of band combinations and visualization. For now, in this case, if you go to this band set, SCP band set, using clip the layers which are loaded in the QGIS, and if you do the band quick settings, now they as per the wavelength, they are placed, there are 10 bands starting from B0 to 3, 4, 5, 6, 7, 8, 8A, 11, 12. Now 2 is a blue band, 3 green band, 4 red band. You can note down the corresponding index or level corresponding position in this band set for defining the color composites. And then band 8, which is NIR, is at position number 7, and sphere 1 is at 9, sphere 2 is at 10. So if I want to generate a true color composite, what should be the bands combination? 3, 2, 1, corresponding to red, green, blue bands, to red, green, blue channel colors. So say how do I do that? You can go to this um, SCP plugin, and here you can type your RGB combination separated by a hyphen and then press enter. If you press enter, it will generate a virtual raster. Somehow it is not active. Let's check. Yeah, it has been generated. You can drag it to the top. Yeah, so this is the virtual band set of combination 321. So you can see this is the true color composite. You can go to the full extent. Yeah, so you can observe that these gray and bright portions are the built up area, and then we have reservoirs, water level, water spread areas, and then you have the Western Ghats covered. Most of the region is either bare soil or covered with the dry grass because it is from February. Had it been post monsoon, you could have witnessed the greenery, green grasslands all over, and you also have patches of forests in the along the Western Ghats. And in the downstream of Pune, you have the agricultural region. These are the agricultural regions on both sides of the river. You will find fields. Um, so you can make use of false color composites like FCC, NIR FCC, where you need NIR band, red band, and green band, which are at position 7, 3, 2 in your band set. So you can select 7, 3, 2. So this is the FCC NIR false color, where you can easily identify the water bodies which are dark, and vegetation, like these are forested areas which are in bright red in color, and in the downstream somewhat lower tone of red, but still they are vegetated areas. These are the agricultural areas. So this similarly there are many other band combinations which can be used to highlight. Now this 321 is something which our eyes, human eyes, see, and this 7432 is something which can be used for not 432, 732, which can be used for identification of vegetation as well as water bodies. So we will make an we can make use of other combinations available in the literature for identification of features. We can also make use of this. Go to ROI options here in the SCP doc. SCP doc, if you have if it is at the time of creation of training input, we have activated it from view, and then the SCP doc, you can check the SCP doc panel. Now here under ROI options you have this display NDVI. You can check this box. So what happens is we can use this NDVI values to check. So wherever you take your mouse cursor, it will also display your NDVI value. So which can be used for identification of the vegetation pixels interactively while selecting the training areas. That will also assist you. Then for creating water, say we will start with creating drawing the just a minute. We can start by, yeah, if you take your mouse, scroll the mouse, you will find that your mouse cursor will show the value of NDVI now, because you have chosen that ROI options. And if you zoom to over reservoir areas, we will start creating the polygons over reservoir areas, and within reservoir you will find that NDVI. Now there is some time lag, so you are unable to immediately see the value of NDVI, but now you can see the negative values over the water body. Now these are extensive homogeneous, spectrally homogeneous areas. So you can create polygons using this draw RY polygon, create a RY polygon. You can start creating polygon by left clicking the left button of your mouse and keep continuing to do that. And when you want to close the polygon, you have to simply right click in using your mouse. Then it will create a polygon. You can make use of the you can create multiple polygons or water bodies, because you have to capture, you have to create training samples or polygons or different reservoirs spread all over the images to cover the spectral variability. For doing that, you can keep press your on your keyboard, you can press the control uh, button and then create multiple polygons. And once you create multiple polygons, you can generate average. You can click on this save temporary ROI to training input, then and give a macro name class of say water, and class name, subclass name as reservoir, and then you save it. Even if you even if you want to incorporate additional polygons, then you can take the help of the options which are available here, like merging highlighted spectral signatures to obtain the average signature. You can then calculate the signature for highlighted items, and you can display the highlighted signatures to spectral signature plot. So we will see that in the just a while from now. So you create multiple polygons or the water bodies. Make sure that while creating the multiple polygons for the same class, macro class and subclass, you press the control key on your keyboard pressed while creating those polygons. And then you can create an average spectral signature. So once you create so many polygons in the water bodies, um, you can click on this button, save temporary ROIs. These are all our temporary region of interest or training sites to the training input. You can press this. Then what will happen is the SCP plugin will start calculating the spectral signature, average spectral signature of all these polygons, and then it will be added to the ROI and signature list. So here I have given the macro class name of water and class name of reservoir. With both the class ID, macro class ID 1 and class ID of 1. I will change the colors here. I will take the deep blue and light blue. Now in this way I had created one training ROI. Similarly, I can in fact you can create multiple ROIs and you can merge them using the options which are available here. You can merge highlighted spectral signatures and then you can calculate signatures for highlighted items. Like for example, if you highlight this, if you want to calculate signature for this highlighted item, you can click on this button. Let us check. Yeah, it is it has calculated and it has been stored in the ROI and signature list as a type R and S. R and S means
ROI has been created and signature has been calculated. You can delete any of the ROI class training input using this button, and then there are other options like this option is for adding highlighted signatures to spectral signature plot. Yeah, now we can let us add it to spectral signature plot. There is only one signature, and you can see how the water has a spectral signature varies along the wavelength. Now it will have the local maxima around blue band, and then in the R band it has a low reflectance. In the NIR band it has very low reflectance, almost zero. So this is one typical spectral signature curve of water. Now let us create under the same macro class of water another class uh, of shallow reservoirs, or let us do it for rivers. So we can create small polygons over here by zooming, or what you can do is you can make use of this region growing algorithm, or activate ROI pointer. You can click on the seed pixel and then select a threshold value. The default threshold value here is 0.002. So check whether it is only water pixels are being selected, otherwise you can decrease the threshold, say 0.001, and then you refresh it, redo the ROI at the same point, or you click on a new point. Yeah, this seems to be more reasonable. So I can select this as an ROI. Let me select more ROIs along the river by pressing the control button with the same threshold. So you have two ROIs, training sites for a river. Now this is a different category of water body. We can keep it under ponds. Now let us see this river at the confluence point. I will select. Now keep in mind that your ROIs should be spread all over the image. Let me click here. Yeah. But is it being added to the polygon list, or it is being recreated afresh? It is being added. So you can add it and then we can merge the training signatures. So I can keep the MCID as 1 and CID as 2. I will name it as river, and then click on this save temporary ROI for training input. So let us have more polygons from different points. So at this point you have selected. Let us also select near the border. So we have these two, and you keep the pressing the button. You can select here the confluence point of Mula and Muta. even select towards the northwest. So you can add it again by clicking on save temperature ROI. Now again you keep your MID and CID as 1 and 2. River, I have to change the name, so add it. What I can do is I can merge both these signatures by using this option of merge highlighted spectral signatures into MCID 3 and CID 1. You can click OK for now. So once it is merged, you can delete the old ones using delete highlighted, and then you can change the CID to 2 and name of class is river. Now let us go for ponds, shallow ponds. Within the city there are many water bodies. Uh, Again we will go for region growing algorithm. You click on activate this and zoom, click somewhere inside number 1, and here why is it disappearing? 1, control 2. If you are doubtful about it, you make sure to click in the right location. You can even have this. So they are located somewhat close to each other. So you should try to have more. Where are they located? Yeah. So let us pick some water body here, shallow body, which is in a different tone. Check here. So we have covered the northeastern part. I think every time you have to lift your finger from control, otherwise it is not adding them. So now I can, I have forgotten to give the proper MC name and number. So it is MC name is 1 and the code is 1 and number is 3, and then the uh, it should, we can name it as ponds. You can have few more ponds from different portion of the uh, images, and then we will merge them. So I have got one, 2, from this point. No, this cannot be. So how to remove this? Let it go. I think I'll start it again. Let me. Bonds 3. And now I will merge these two. Then I will delete them and rename the code CID as 3. Now let us use a different band combination. Now I want to delineate vegetation areas also. I will do it using this combination only. So let me go to brighter red areas where I will use the um, you can even go to the ROI options and display the NDVI so as to get a better idea. So NDVI is here pretty high, 0.6 and 0.7. I can make a polygon here, manually draw the polygon where I have high NDVI. Yeah, have to draw the polygon. Yeah, it is done. So this is forest. Let us look for other regions. Yeah, here it is pretty high, 8.82. These are dense vegetation areas. So again, press Control, click on this polygon. I hope I have created the polygon. Yeah, it is getting generated. So this requires due diligence and application of mind at the time of creation of training input. So for the purpose of demonstration, I think I should not spend lot of time in this. So again here I can have another polygon. Whether it was created or not, yeah, it is getting. Then you can give the macro ID of 2 and class ID of 4, macro class name as vegetation, and class name as forest, and you calculate the signature. So you can check your training layers which have been created, which are in the form of dark polygons. You can check here these two. These are yeah, these are one is forest and another is water.
You can make use of other band combinations which are available in the literature. For example, the band combination of SWIR2, NIR and blue in red, green and blue channels respectively will be useful for identification of agricultural fields. So if you want to implement it, you can check your band set. SWIR 2, that is B12, which is at position 10, and NIR B8 at 7, and then blue, which is at 1, 10, 7, 1. Just check this. 10, 7, 1. Press enter. So you can see in the downstream area of Pune, on either side of the river you have these agricultural fields. So we can make use of region growing algorithm as well as NDVI value to create polygons for macro class of vegetation and subclass of crops. Let us say the threshold is 0.01. Here NDVI is as high as 0.74. So you can create such a macro class, such a polygon, and then you can save it as vegetation macro class and crop micro class. You can further decrease your threshold from 0.01 to 0.001. You can do trial and error to see whether you are choosing uniform area under your polygon. Similarly, for built up area in the same combination, you will find that built up area is gray in this combination of 1071 SWIR, that is SWIR 2, NIR and blue. The built up area is gray, and again you can make use of this region growing algorithm to create a new macro class of built up area number 3, and then the micro class or subclass of buildings. You can decrease the threshold. Similarly, you can create a class of built up a macro class and roadways or pavement micro class or subclass. You can make use of, you can add a base map of, now this ndvi value is distracting us. I am checking it, I am keeping it off. You can add a high resolution satellite imagery of Google satellite, and then you can make use of it, even though that may not be from the same period, but still there are some classes which will not change with time, like these motorable roads, like these are arterial roads. If you want to create a new class under built up macro class, subclass of pavement or roads, you can choose your region growing algorithm and choose appropriate threshold spectral distance. Now you can see when I am clicking on the road, you can see it is actually giving me a polygon along the road with uniform spectral characteristics. So I can choose this polygon and create a new macro class of built up area and micro class of roads. Often there is lot of confusion between urban areas or built up areas and bare soil. So there will be lot of misclassification. In literature, you will come across one band combination which is SWIR2 red and green. SWIR2 in red channel, red in green channel, and green in blue channel. So in our case, our band set definition, it will be SWIR2 is 10, red is 3, and then green is 2, that is 10, 3, 2. So if you make use of this combination 10, 3, 2, you will find that bare soil will be light green in color, whereas built up area or urban buildings will be gray in color. You can just notice the combination. So this is bare soil, and then these are the buildings. So here you can see that you can make better distinguishing between you can better distinguish between the bare soil and built up classes, built up area classes using in this combination. So you can make use of this combination for creating a new macro class of bare soil, and subclass you can name it as bare soil or wasteland, whatever you want to. So you repeat this process, you try to create under the 4 macro classes of water, vegetation, bare soil and built up area. You create as many micro classes as possible. So I try to create 10 micro classes or subclasses, and once you have a good number of training samples for each of these classes spread over the whole area, whole image, you can proceed to the next step of classification.
Before generating the classification preview, you can just have a look at these colors. You can slightly make changes. Vegetation should be green, and forest, trees, cropland, I will take it as pink, and then built up. Customarily built up is represented in red, and then roads I will go for gray, buildings I will go for orange, then bare soil, yellow is fine, uh, again under bare soil another kind of yellow, another then rocky outcrop, you can go for brown maybe. So you have this color combination, and now let us generate classification preview before final classification. This changing of region of interest, and then it is an iterative process. If you have more ground truth information, ground information, you can create more better training sites or the ROIs spread over entire images, and each class having a high representation of at least 5 to 10 ROIs. You check the band set, active band set, if it is still the same. I think it is the same. So here the input band set has to be 1. Now you go for band, under band processing you go for classification. Before that you can see the preview, activate classification preview pointer, this one, and then you can give the set preview transparency to 50% so that you can see what is on the base, and set the preview size 500 pixels. Now you go to processing, SCP, band processing, and classification. You select the input band set as 1. There is only one input band set, and use class ID for training, and then use the maximum likelihood algorithm. Other options are maximum, minimum distance, multi-layer perception, random forest, spectral angle mapping. Now we are going not into those details. We will go for maximum likelihood, which is mostly used. You activate this classification preview, and then you click anywhere. But this is outside, I think it is outside, so it is somewhere here. So let me zoom near Kadakwasla Dam. Let me click here. So it will generate a classification preview of 500 pixels as selected, and if you are convinced about the classification preview, you can generate the classification preview at some other location, and then you can finally generate your land use land cover map, making use of class ID. There are 10 class IDs that you have generated. So it will take some time. Let it calculate, let it generate. So it has generated classification preview. So it is the lake and bare soil and some buildings have also been represented. Let us check at some other location. You can check the classification preview here. The roads are being represented pretty well. Uh, the greenery along the canal has been represented as a cropland. Let me click somewhere here. So you can see, is this the rivers? They have also come out to be pretty well. The roadways have come out to be well. These are the rocky outcrops. I don't know what it is. We have to check on the field. But the built up area is also, buildings is also prominent in the city, as can be expected. The tree portions, these are the trees. You can see, you can check the high resolution base layer. uh, so trees are represented well, this class. The roadways are represented well. Even the bridges are represented well. These are the roadways. The river has come out to be fine. Then but there is some misclassification, as this is the region where there is lot of buildings, but it has misclassified not just buildings but also even the large portion it is showing as roads. So some confusion between built up area and roads that can be expected, because both have similar spectral characteristics. And if we go to the downstream of Pune and you again do the classification preview, it should have more of a cropland as expected. So all these are fields which are cropland, as you have depicted by uh, pink color. These are all the croplands. River, and along the river there is vegetation, which is either in the form of trees, or sometimes where the thick vegetation is there, it is being shown as forest. And in between there are some built up areas. Here you have the built up area and some bare soil. It has been misclassified as rocky outcrop. Maybe I should have given more training inputs for rocky outcrop. So let me go to the region where you have the actual rocky outcrops. Now here, if I generate it, if I generate the classification preview here, let us see. So this is your water body. Somehow in the water body you got another class, which is maybe it is a shade of blue, I don't know. So here you have yeah, the thick forests, as you can see. These are represented as forest, rightly classified. And then the bare soil here, it is classified in yellow. But the only issue is with the rocky outcrop, which has come out to be very prominent, which should not have been. So I have to give more training input of rocky outcrop. So this is a fairly good classification that we have generated. by spending about 1 hour time. And in case if you generate very good training inputs with lot of more ground information, and diligently if you pick up the training input from all over the images, you can definitely have create a very good output LULC map. Now here also you can see the roadways have come out to be very good, and then the bare soil, it is in yellow, and then some part is showing as rocky outcrop. The buildings, everywhere the buildings are there, and they are represented in orange, that is built up area is high. In there are some areas like maybe their parks are empty, these are actually fields, they are represented in pink. This is a big area which is bare soil. It is represented in yellow. So you can just verify, you can do the assessment. I think it is reasonably good. So we will try to generate for the whole area. For generating for the whole area, you can go to semi-automatic classification plugin, band processing, go to classification, and again you check the input band set 1. Then you can select the class ID, maximum likelihood, and then you can run. It will ask you to save where you want to save. Then in the solution you can save it as Pune supervised classification. This we are doing it by class ID. We will also do it by macro class ID. Then we will also see how it looks like. So if you run this, it will generate the whole LULC map for the whole extent of Pune. It will take some time, so let it generate.
That's all for this session on land use land cover mapping using QGIS. As you might have noticed, generating a highly accurate LULC map requires creating a large number of training samples that adequately capture the spectral variability of different land cover classes. It is a very time consuming, time intensive process, and there will always be room for refinement and improvement. The main objective of this session was to introduce you to the semi-automatic classification plugin in QGIS and demonstrate how it can be used for generating better LULC maps and better and accurate LULC maps. Thank you very much.